Okay, this is our last video for section 5.4. We're going to talk about independent events and mutually exclusive or disjoint events. We've been using this language, but one of the things we really need to be able to do is to tell the difference between them when they apply, and we're going to actually look at the definition in terms of probability calculations. So it's important to be able to determine when events are independent and when they're mutually exclusive or disjoint. And it's also critical to know the difference between the two. So use the following criteria in the example below to answer the questions. So here's the thing we have to really focus on. For two events to be mutually exclusive, you must have a single trial. You're only selecting one ball, rolling one die, choosing one student, one trial. That's when you decide, okay, one trial, are these two events mutually exclusive or not? For independence, you have to have a multi-stage process, because independence has to do with, remember that without replacement makes them dependent, right? So it has to be a multi-stage process for that to happen, and with replacement makes them independent. So we're going to use these calculations to answer the question this time. All right, in a recent poll, a sample of freshman and sophomore high school students were asked how many school clubs they had joined. The results are presented in the following contingency table. So the number of clubs, 0 or 1 or 2 clubs, 3 to 4 clubs, or more than 5 or more clubs. And we looked at the freshmen and the sophomores. So out of a total of 80 freshmen and 80 sophomores, we can see how many signed up for how many different clubs. And we have the totals here that add to 160 and here that add to 160. So in part A, they're just asking us, are the events freshmen and 1 to 2 clubs mutually exclusive? So if we're checking mutually exclusive, we're talking about a single trial. So I'm just going to make a note here. Single trial. It has to be a single trial because that's the only time you could have mutually exclusive events. So in other words, what they say for a single trial, it says calculate the probability of A and B. If you get 0, your answer is yes, they're mutually exclusive. Otherwise, they are not. So let's calculate the probability of freshmen and I'm just going to put 1 to 2. Okay, so this is a single trial. In a single trial, the word and doesn't mean multiplication because it's not a multi-stage experiment, so you can't have multiplication. What it means is you picked one student and they were a freshman who joined 1 to 2 clubs. So there's only one place where that happened. Freshmen, 1 to 2 clubs, right there. That's it. Those 46 out of your 160 students, that's the probability that if you pick one of these 160 students, they are a freshman who joined 1 to 2 clubs. Well, we're looking to see if probability of A and B is 0. Our answer is yes, mutually exclusive. But this is not 0. So our answer is no. Are the events freshmen and 1 to 2 clubs mutually exclusive? No. Because the probability of freshmen and 1 to 2 clubs is not equal to 0. Okay, are the events 0 clubs and 1 to 2 clubs mutually exclusive? Again, if they're asking about this, it has to be a single trial because that's the only time mutually exclusive or disjoint applies. So what's the probability if you select one student, they said they joined 0 clubs and they joined 1 to 2 clubs? Okay, 0 clubs, 1 to 2 clubs. Notice there's no overlap. When we did freshmen and 1 to 2, there was this overlap right here, 46. But 0 and 1 to 2, there's no way for it wouldn't be appropriate to allow a student to tell you that if you're taking a survey. They can't say I didn't join any and I joined 1 to 2. So the probability that you select a student that has said that is 0. That can't happen. We wouldn't allow that to happen in a survey. That wouldn't make any sense. So, yes, these are mutually exclusive. They are disjoint. And another clue, like I showed you way back, was in a contingency table, if there's overlap, they are not mutually exclusive. They are not disjoint. They overlap. But here, they can happen at the same time, right? But here, they cannot happen at the same time. Part C. Are the events sophomores and 1 to 2 clubs independent? So now they're talking about, oh, they must be talking about a multi-stage process, because that's the only thing that independence and dependence applies to. So for multi-stage, we're going to check to see if the probability of B is equal to the probability of B given A. In other words, they're independent if it doesn't matter that A happened. The probability of B is still the probability of B. You know, if A happened, but with replacement, if you put whatever back that A took, for example, then you still have the probability of B being the same. So that's what we're going to check now. So the probability, we want the probability first of sophomores, and there are 80 sophomores out of these 160 students, or 0.5, half of them were sophomores, right? And now we want the probability of sophomores given that we already know this student said they joined 1 to 2 clubs. Okay? We already know it's a student who joined 1 to 2. It's a student in here. What's the probability that it was a sophomore that said that? Well, the probability that it's a sophomore that said that is 46 out of how many? Well, we already know it's somebody who joined 1 to 2 clubs, so 46 out of 92. We're only looking at these because we already know it's a 1 to 2 club student. So that one is 0.5. So in this case, the probability of S is equal to the probability of S given 1 to 2 clubs. So yes, in this case, these would be independent because you get the same probability whether you just have probability of S by itself or probability S given 1 to 2 clubs. Okay, last one. Are the events freshmen and 3 to 4 clubs independent? Independent, multi-stage process. Can't have independence with a single trial. That doesn't make any sense. Okay, so let's see the probability of a freshman. Okay, there are 80 freshmen and 160 students, or half of them are freshmen. The probability of a freshman, given that we already know 3 to 4 of them, they join 3 to 4 clubs, right? So we already know it's a student that joined 3 to 4 clubs. What's the probability that's a freshman? Okay, so the 3 to 4 clubs is 23. And how many freshmen are there in that 23? Just 9, right? So that is 0.391. Well, since the probability of freshmen is not equal to the probability of freshmen given that we already know it's a student who picked 3 to 4 clubs, those aren't equal, so our answer to this would be no, not independent.